Okay, so the really two things we got left. This and one other little rule that we'll pick up, and then we'll be done with these logs. Okay, bases other than E we need to look at, because not everything is log, LOG. Log, LOG is base 10. LN is base E. Not everything's going to be those. So this is the everything else. So if you're taking the derivative of a base other than, so they're calling it A, look at this. You take the ln of the base times itself times the derivative of the exponent. This is really just like the rule for e to the x, except they've added this first little piece, right? I mean, really. So this is the e to the x rule pretty much, just with this added on. Okay, so any other base there. All right. If it's in log form and you're taking the derivative, notice log of other base a, it's derivative of this over ln of a times u. Does this look familiar? This should look familiar too. It's the ln rule. If I cover this up, that's the ln rule. They just added in this. And on here, if I cover that up, so they've taken the e to the x rule and added that onto it.
And that's
and the
almost
ln
the e rule too. It's just we were using it with an understood e.
Yes.
And now it's
yes.
Okay.
So really, that's all. So if that'll help you to remember how to calculate these aren't that bad. All right. So let's do a few here. So for instance, if we've got 2 to the x and we want to take the derivative then. So based on that rule we just had,
ln of 2.
ln of 2 times 2x
times 2 to the x
times 1
times 1. It's just following that rule. So pretty much just this then. And let me see. They usually put it in this order. Going by the rule, it's the ln of the base times itself times the derivative of the exponent. And this is probably how they'd write it. And that's as far as you go. Okay? All right. So on the next one then, did I move too fast? You need it? You need me to go back? I'm sorry. I'm sorry. I got carried away. Okay. All right. So on this one then, what would you have?
ln to the 4
ln of 4
times 4 3 to the 4 to the 3x times 3
times 3. Yeah. So then they would probably just arrange it so that it's.
So we can do 12. 3 to the x.
You can't say 12 e to the x because the 3 is really not. 3 is to the first. Here's how they wrote this one. This is how they wrote this answer. They said this times this. I don't think it would matter what order you could put. I think you could put this and you could put it in there or you could put it there. As long as you know that the 3 can't combine with that 4 because
Why not?
they're different exponent.
Don't you just add the exponents if they multiply?
If you have the same base.
But they don't have a.
The base of this one is 4. The base of this one is 3. So like if this was 4 right here, then you could add exponents. So that's the issue. So that's as much as we can get out of that. All right. So let's look at the next one.
Or product rule.
Product rule. All right. So product rule here. Okay. So first times
Log or ln3 times
3x times 1
plus
times 1. Okay. Plus
3 to the x
3 to the x.
2x
and then you just clean up as much as you could right here. Let's see, that,
Could you combine the 2x and the x squared?
hang on, the two, that two, well,
What?
Never mind.
You can
never
put, you can do the 1 and the x squared, but I
Alright.
mean the 1 doesn't do much.
let me look and see here what we got. So there's no good way to put these in order here. I mean, really, because nothing combines within its own little thing.
Those can't combine either.
Now, pretend, I mean, that's fine, but pretend just a minute. Pretend that we're looking at the multiple choice answers and they broke it down just a little bit more. Just a what if. The
And
3 to
take out
the
a 3
x
to the
could
x.
come out, something else could come out.
An x.
Alright, so you could take out an x, 3 to the x, only if you're forced to, you know. So that would leave me with what from here?
X.
Plus,
X ln of like 3
Plus 2x.
2,
plus 2.
because you took an x. So, if necessary, you could do that, only if you're pushed to. But that's about as much you could do there. Alright, so let's use the other rule. We've been stuck on the first rule. Let's use the other one, the second rule.
Another one.
Yep.
Another one?
Y'all had 2 rules.
Another one.
Stop it. Okay,
Lots of those.
alright,
Key success.
Sine x. No,
alright.
what's the derivative of cosine?
Okay, look, remember that one was derivative over itself, but also on bottom they
With
put an
a-
ln of the base.
So we
Okay,
have negative sine
derivative of
negative.
cosine, yes,
Negative.
negative sine,
over ln of 10 times cosine.
now look, back at that rule and make sure you see why. Derivative of this over its original, but also in the bottom was the ln of 10. And notice, it is the ln per the rule, even though we started out log.
And now we can
Because that's what my brain just said, wait a minute, and that's right though.
make that into a negative. We can do
You could.
ln of
How would it look though? It's a negative tangent.
over.
If you had to, you could say that. Very good for y'all seeing that. So that would be if you don't see your choice and you gotta go a little further. Very good. All right, one more. One more.
Can we rewrite it?
We rewrite it, very good. So let's start out, we'll call it log base 4 of x squared plus 1 to the,
1/2.
now,
Quotient rule. Okay.
we could do, what could we do?
Chain?
Chain,
Alright, that's
very
not
good.
chain.
So we're gonna be using that rule for the log, where it's derivative over log of whatever times itself, but we're doing chain to it. Alright, so derivative would be, Of this.
1/2 x squared plus 1.
To the negative 1/2 times 2x
yes,
all over
ln
of 4 times x squared plus 1 to the 1/2.
alright. Derivative per the chain rule over ln of the base, which was 4, over its original. Alright, and we can clean up a little
You
bit
can do
here.
the 1/2 and 2x.
Okay, so the 2 here and the 2 here would go away and that'd be
X.
nice.
to x,
Can you move the x squared to the bottom?
Yes, we can,
and it combines with that other one.
and it'll combine with that.
Making it x squared plus 4.
Yeah, you can cancel out your
Okay.
square
1/2 plus 1/2 would be 1.
Alright, so they're saying this goes down and combines here and it becomes positive, so it'd be a half plus a half as a whole. Alright, so then really all we got on top is the x, right?
Mhm.
And then on bottom we got ln of 4 times that x squared plus 1 to the first now, because when that bumped down it became to the first.
and then that's it.
And that should be good.
Yeah.
told y'all, you can stop that if you want to.